start to record. I'm not on mute. I hope. Well, looks promising, but okay. Final exam review day. So first thing, or like the main thing, I guess, that I want to do today is go through and just talk about all the things we've learned, all the potentials for the final exam. And also I've grouped them into, well, questions, I guess. So this practice final is definitely way too long, right? But it just gives you an idea of all the different types of problems that you need to be prepared for. It is test 1, 2, assignment 8 and 9. Well, 9, it just says see assignment 9. Smushed on, because you're still working on assignment 9, but those are the types of problems that you can expect. Okay? So, all right. So what I want to do is just go through this list and then give you time to have a look through the practice final and just kind of start working on some problems maybe, and then you can ask me questions and just kind of figure out what's hard, what's not, and then maybe I'll take requests for what we want to actually go through on Tuesday. Yeah.
Just because assignment 9 is not on here on Tuesday, could we not necessarily do one of these ones, but do a similar one?
For sure. Yeah.
Because I assume we're not getting that mark from that right for the final.
No, but I'll post those solutions right away, so I won't accept any late assignments for that one, because then you'll have the solutions right on Tuesday. So maybe, I don't know, take pictures of your work or something so you can check it. Good. All right, here we go. Final exam review. How did we end up here? I know, so proud. I actually thought I would eat into the final exam. They're buffer days. So for me, I'm like, but we did it. All right. So I've broken it up into kind of from test 1, from test 2, and then kind of new material. So from test 1, kind of broad strokes, the first question. And what I like to do usually is I just like to keep them in the order from the review. So the first question will be a simplify this thing, right? Simplify an expression. But you've seen that on the other tests too, right? The practice test has the same format as the actual test, right? So there's no kind of curveballs or anything like that. I don't like to do that. Simplify an expression. You've got examples on there, but what just struck me is I should have added, this can include exponents and logs, but nothing crazy. And exponents and logs are from test 2, right? But now we've kind of seen it all, so that can be part of simplifying an expression. And I'll make sure to get you guys some more practice because I don't think it was on here. No, it's just the solving. Similar. The second question is going to be a solve for X or solve for P or solve for whatever type of question, right? So we've seen that on test 1 and on test 2. So I put those questions next to each other on the practice final. And so solve for X. Right. which can include exponents and logs again.
Do you mean just like bringing the natural log in and like testing like that kind of stuff?
Yeah. Or if you have something like the natural log of 4 plus the natural log of 5 minus the natural log of 6, right? You can condense this into the log of 4 times 5 over 6. Something like that. Okay, so simplify, solve for this, solve for that, blah, blah, blah. Those should be nice warm-ups, right? And then there's a question from the stats section that we did, right? So where you have to find the mean, median, and mode, and then the MAD, the standard deviation, the variance, right? All those fun things. And then we threw in a little bit of regression, right? And so essentially, if you have a linear equation, then can you use it to predict future values? Right? So we've got the mean, median, the mode, the MAD, the standard deviation, the variance. Now it's been a while, right? So you might want to brush up on those. Regression. Regression, right, is given a linear equation use it to predict values. I give you the linear equation and I give you a value and I ask what's the predicted y at this point. You plug it into your linear equation and that's it. And then solve. The fourth question is going to be one of two questions, right? So it can either be an absolute value function or a quadratic function. Okay? And we have to find things like the vertex, the zeros, the slopes, the y-intercepts, graph it, find the domain and the range, usually using the graph. And then for the quadratic function, we also found the average rate of change. Okay. And so those were all on test 1. So I'm going to put it as question 4 here, right? Because it's just one of these. One of an absolute value function which has the form f of x is a times the absolute value of x minus h plus k, or at least if you put it into that form, you'll be able to easily find the vertex, the zeros, blah, blah, blah. Right. Tricky because it means you have to have both options ready to go on your formula sheet, right? And so definitely when you're reading through all these problems, right, you need to be ready for all of these types of problems that I've given you, right? So even though it's choices, so you have to write really small. You're allowed to type it up if you want, right? As long as it's just on one page, I don't care how you do it. Oh, but Bevan, who taught it last year, he did tell me that I should emphasize that you can't use Post-it notes. I guess someone had put like just a ton of Post-it notes on a page. And so you may not do that. It has to be 1 page, double-sided. So the absolute value function, which has that form, or a quadratic function, which has the form very similar, right? A times x minus h squared plus k. So one of these, to find the vertex, the zeros, the slopes, the y-intercepts, if there's more than, I guess it's slopes, y-intercepts, although both have 2 slopes, but nice. Graph the function. And then state the domain and range. Also find the average rate of change if you have a quadratic function. Find the average rate of change for a quadratic function. So that's test 1. Any questions about that? Probably have more questions later, come Tuesday. But definitely if there are things that you're kind of worried, oh, is that going to be on there? Is that something that I need to focus on? Then just ask me and I'll let you know. Right. Okay. Moving on then. From the test 2 section, did you not get one? Oh, sorry. From test 2, I realized that I hadn't put polynomials, I think, on test 2, so I just put a couple extra on the practice final. Sorry, practice for the final exam is what I should have named it. It's not really a practice final. So, oops. On the final, what question number are we on? 5. We did talk about polynomials. We talked about their graphs, right? Not the general, but not exactly what they look like, but we did talk about their end behavior, right? And so we talked about polynomials in general, what's the leading term, the degree, the leading coefficient, and those are all kind of breezy. And then we also talked about graphs, properties of polynomials. And then we also did some problem solving, Right. So, and problem solving. Right. On the assignment, on assignment 4, you had to find the function for the volume of a cylinder, I want to say. Right, so it was like a cylinder with caps. You didn't have to solve anything. You were just asked to estimate things, which you guys didn't seem to like. So you guys don't like imprecise things, I guess, and that's fine. But yeah, so we also did kind of more concrete things like, okay, so I think he was farming, he had llamas and he had to enclose them in a field, but he had the river, and then so he had 200 feet of fencing or something like that, and he wanted to optimize the field, right? And so then we were able to build a function for the length of each size to find the area of the field, right? Things like that. We also talked about the volume of a box, and I think that's the one that I landed on to put on here. I think of course. Thanks for grabbing it. Okay, so we kind of had bigger fish to fry on test 2, right? How did you guys like some function arithmetic? Not too bad, right? On test 2, we saw it in the form of difference quotients, and I'll probably just do the same thing again, right? And so we said function arithmetic solve and find the domain and range is an option, right? Function arithmetic are things like f of now I'm drawing a blank. F of x minus g of x. Yeah. Is f minus g of x. There we go. Things like that. But we also saw it on test 2 in the form of difference quotients. Which in general is f of x plus h minus f of x over h. We care about those because it leads us into the limit definition of the derivative in calculus. So we have to have a handle on those. But for us, we just did the difference quotient, right? And so we did it on test 2. Seems fair to do the difference quotient on the final exam as well. Okay. Any questions so far? Just absorbing, trying to get nervous. But so far, everything seems okay. Hopefully. Question 7 is going to be on function composition. Oh, I should highlight here. It's one of these. Right. Probably more like that one. Function composition, right? Or kind of more elaborate inverse functions. Inverse functions, so we have to test if it's 1-to-1. And then we confirm that it's the inverse using function composition, right? So inverse functions kind of capture all of that activity, right? So, and then use function composition to confirm the inverse. Probably more that option. Rude, I know. But on the plus side, you won't have to find the domain and range. Whereas if it was straight function composition, I guess I should add that on here. With domain and range. But for inverse functions, we did talk about the domain and range, right? But as long as you are able to find the domain, then the range kind of falls out because you'll find the domain of each of your functions, and then you'll have the range. Right? All right. Very vague. Question 8 is on exponential functions. Now, we landed on things like the rate of decay, so the decay model, the growth model, the temperature, the law of cooling model, right? So we had all these models. We've got the doubling time model, right? So you need to be prepared for any one of those, which is kind of annoying, right? But you can do it. And just summarized as exponential functions. Right. Things like doubling time, population growth, decay model, law of cooling or heating. All those things are kind of under exponential functions, right?
Again, which one of those?
Yeah. So it's just one question, so it's going to be one of those, which I'll highlight.
With those questions, will you give us one line in the question or no?
No, because I'm that mean. A lot of those formulas, right, they were pretty wordy on the page, but you can probably condense them into something. Because you really just need the formula. K is going to be the same, right, regardless, or how you solve for K. It's going to be the same. Okay. Question 9, equally vague, logarithmic functions. there's not as much to choose from here for logarithmic functions, right? We did a pH one, and that is actually the ideal pH for goldfish. Remember on test 2, I gave you the ideal pH for goldfish. And so I actually stole these, the majority of these from your tests, because I know that you don't remember them, but they are the best gauge. Yeah. Oh, the blank ones? Yeah, sure, but they're all smushed together on here too. So yeah, all the relevant questions from the test. But yeah, I can do that because I've just posted the solutions, right, with the, so yeah. Where am I looking at here? Logarithmic functions. If you have a look at question 13, that was really the only one that I was able to kind of manage, right? So if you've got the pH is the negative log of H plus the hydrogen ion concentration. And then part C, I did research it. And the ideal pH for goldfish is between 7.2 and 7.6. So why you would want to know the ideal hydrogen ion concentration, I don't know. But that's how you would find it. So basically it's going to be a pH function for logarithmic functions. There's lots of other things that we can do, but I'm trying to make it wet appropriate. Some of it's making it pretty hard. All right. So, any questions about those? So those are all from test 2. Now we're getting into new material. Things that we've covered, right? But what's tricky about, well, this course, I guess, is because we spend a lot of time kind of building blocks, and then it's not until the last few sections where we actually apply all the things. And so it feels like we talked a lot about, you know, different angles, but then we use those to talk about reference angles, and then we use the reference angles to solve bigger problems. Right, so they are all baked in, but just so we have a list of things that we've covered, right, because it feels nice. We talked about radians, kind of generally to or from degrees at its, the basics. We also talked about the definition of radians, but that's not going to come up. The problem with a group assignment, I guess. Yeah. So, and then we talked about, well, how do we graph angles, which we use later, right? But just in general. We talked about circular motion. That's when V is R times omega. Right, omega is the angular velocity, V is the linear velocity. We did talk about the equations of motion. X is R times cos omega t. And Y is R times sine omega t. That was on your assignment. and it was a jerk move, but we had done an example just like it in class. So a jerk move, but not really. So should you expect to see something like equations of motion on the test? No, right? That's why it's not. It's just in the things that we've covered. But we also talked about reference angles. On the unit circle and any radius. We kind of started on the unit circle because things are kind of nice and clean on the unit circle because the radius is 1, right? And then we expanded and all those things applied for any radius as well, but it kind of made our formulas a little bit nastier. So we were on question 9. So for question 10, it's one of, you could have to graph a sine curve, you could have to graph a cosine curve. If you're given a graph, find the function, right? Using either sine or cosine. So those are all the things that you did on assignment 8. Graphs of sine, graphs of cosine. Given a graph, find the functions using sine and or cosine. Right, so that's like question. Oh, here it is. Question 2 and 3 on assignment 8. See questions 2 and 3 on assignment 8. In fact, I think those are the ones I threw on here. Yeah, just for more practice. Question 11 is on the circular functions. The circular functions, and it's going to be one of either find all angles that satisfy tan theta equals √3, for example, or find all circular functions I have in my notes, I have given X, Y, and R, right? So if you have a look at assignment 8, for example, question 4, right? I give you sine theta is 3/5, right? And then I tell you that theta is in quadrant 2, right? And so you don't know what x is, but you're able to solve for x, and so it's given. Given x, y, and r. Question 4 on assignment 8. And this is question 5. Oops. So I kind of did them in, I guess, different order, but it doesn't matter. Yeah. And then there's 3 questions, but I might condense it to 2 depending on the length, because this, I mean, I'll try to keep it pretty reasonable. You do have 3 hours to write it, right? And so it is more time, right? You can do a lot in 3 hours. But then, so right now I've got it slated for 3 more questions, and that's on the law of sines, the law of cosines. And that's mostly to try to be nice, because I think those are pretty fun and pretty easy, right? And so correct me if I'm wrong, though. So question 12 is on the law of sines and find the area. That can be a word problem, or it could just be straight. Here are some angles. Oh, and if you haven't tried, there is one triangle that doesn't exist on assignment 9, and that can happen, right? I give you sides and they just don't match up, or the angles are just too big to be able to form a triangle, right? So that can happen. So when you try to compute it and you're feeling confident, and then you realize, oh, I actually can't find this angle, for example, then you can just say that this triangle does not exist. Right? So that's why on assignment 9, in question 5, it says use any method to solve the remaining sides and angles, if possible, and find the area. Right? Okay. Question 13 is going to be on bearings. So definitely a word problem. And then the last question, which I'm tempted to just smush together with question 12, but it just depends on, I'll kind of get your opinion on it after, but that's just going to be the law of sines, or sorry, the law of cosines. And find the area. All right. I'm especially looking for, so those are all the questions, those are all the things, all the mega things that we have covered in this course, all things that you're kind of expected to have stored away to use at some point later on. But I am kind of looking for what you would like to see for these questions. Do you like these questions, or do you prefer to have fewer of them, right? Because one thing that I could do is I could stretch these out and just, right, make the other ones a little bit easier if you prefer these problems, or I can put this one into here, and then you have to, just like on assignment 9, right, where I just give you a list of all these things and you have to solve the triangles. So I can kind of make this as large of a portion or as small of a portion, kind of within reason, right? It has to be 2 questions, but I can make it kind of 3 questions, 2 questions. I don't know. So kind of have a think on that. Maybe it'll be easier to answer once you've had a look at assignment 9, right? Now that we fixed the typo, it's very solvable on assignment 9. Fine, I'll eat my words once more. Mike was right. Happy? All right, how are we feeling? Public apology number 3. Feeling pretty good, pretty reasonable, pretty overwhelmed, pretty scared. So like I said, I guess that didn't take as long as I thought it would. But I've given you the practice, should be practice for the final exam, right? It's not a practice final exam because it's way too long, but it does give you practice for all of these types of problems that you need to be able to handle, right? And so maybe as you're doing these, right, definitely keep track of formulas that you're using, things that you're looking up, right? Because you want to be able to smush all those things onto your formula sheet, right? So same thing as before, right? Your formula sheet. Make your own formula sheet. And I've given you some formula sheets, right? Some random formula sheets that I've pulled from places just to see how you could condense things, right? For example, on, where was it? One of these. Oh yeah, on this one, important formulas in trig, right? It's got the law of sines and cosines just kind of smushed down here, right? So it doesn't have to be a big thing, right? As long as you know how to read it and use it, right? Then it can be as small or as big as you want. So make your own formula sheet, right? Is it 8.5 by 11? Or 1 letter size, yeah. 1 letter size page, sorry, 1 letter size page. 2-sided. And like I said earlier, you're definitely allowed to print it, like type it up on a computer, bring your font way down, because I know I have a hard time writing small, right? And so if you find that that's easier, then that's great. But so same as always, but now you've covered all the material, so it felt like probably a lot of space for test 1. You could basically put anything you wanted on there, and then test 2 got a little more crammed, and now test 3 we have to be a little bit more crammed, right? But you've probably logged some things in your brains. And so you're allowed to make your own formula sheet, and I hope that you'll use that to its full potential.
Is the exam like an even set of everything, or is it more focused on stuff that we want in test?
I mean, these are the questions. So I would say, so the last 3, 4, 5, the last 5 out of 14 questions are from the new stuff. And so sort of even with a little bit of emphasis. Because I mean, that beginning stuff, we use that later on as well, right? So it's hard to kind of emphasize that. But yeah, so relatively evenly spread. Mm-hmm. Yeah, any other questions? No? Okay. So like I said, today, I want you to just kind of have a sit down with this practice for the final and just kind of figure out some key questions that you would like me to go through, particularly on Tuesday, right? And then I'm gonna ask Allison if C140 is available, if you guys want to do like a review session closer to the final. I'm thinking maybe on the Friday, I don't know, because I've got department meetings on the Thursday, but I'm here on the Friday as well. So I know that's close to the final, so you should probably be pretty prepared, right? But there's always kind of last minute questions. And so I'm gonna look into that and just kind of, unless you don't want it. I don't know. I guess I should ask, would you want that? Yeah, okay, great. I assumed, but you know what assuming does. So I'll ask about that and see if I can kind of book a slot for Friday. Okay. So potential review session on Friday. All right, stay tuned. Okay. So, all right. I'll leave the rest of the time for you to kind of skim through, or maybe even work on assignment 9. You can ask me questions about it. You're welcome to. So just kind of work on problems, or honestly, you're all adults. You can decide what to do with your time. So, all right. Any questions before I stop this recording? All right.